Some of these bombers were built more than half a century ago, yet they can still deliver powerful weapons across enormous distances. Others combine speed, stealth, and long-range missiles to challenge the world's most heavily defended airspace. These are the 7 most feared bombers still flying today. And the final aircraft was specifically designed to approach its target before the enemy even knows it is there. At first glance, the H6N looks like a bomber that belongs to another era. Its basic design can be traced back to the Soviet Tu-160M of the 1950s, but China has transformed this aging airframe into a long-range carrier for some of its most powerful missiles. Publicly unveiled during China's National Day Parade in 2019, the H6N is the most strategically important development in the long-running H6 family. The first major clue to its expanded role sits directly above the cockpit, a refueling probe that allows the aircraft to receive fuel while airborne. In June 2026, official footage showed an H6N refueling from a Yu-20 tanker, offering a rare look at how China is extending the bomber's operational reach far beyond its coastline. Powered by 2 D30 KP2 turbofan engines, the H6N can reach approximately 1,050 kilometers per hour, but unlike several bombers later in this countdown, it remains firmly subsonic. Speed, however, is not what makes this aircraft dangerous. Rather than relying on a massive conventional bomb load, the H6N features a specially modified section beneath its fuselage that allows it to carry a single, oversized weapon along its center line. U.S. defense assessments indicate that this configuration was developed for an air-launched ballistic missile that may be capable of carrying either a conventional or nuclear warhead. This means the H6N does not have to fly directly over its target or force its way deep into heavily defended airspace. Instead, it can launch from a safer distance, potentially placing military bases, naval forces, and other strategic targets across the Western Pacific within reach. The aircraft itself is neither stealthy nor especially difficult to detect, and its large radar signature would leave it vulnerable if sent into contested airspace without support. But the H6N was never designed to fight like a conventional penetration bomber. Its real strength lies in launching standoff weapons while operating alongside tankers, fighters, reconnaissance aircraft, and airborne command platforms. Together, these supporting systems allow an airframe rooted in the Cold War to perform a far more modern and far-reaching mission. The H6N may not be the most sophisticated aircraft in this countdown, but it has given China something it never previously possessed: a refuelable, nuclear-capable bomber, forming the airborne element of its emerging nuclear triad. And for an aircraft whose design reaches back more than 70 years, that transformation is exactly what makes it impossible to dismiss. Long before stealth became the defining feature of modern bombers, the Tu-160M Backfire was built around a far more aggressive idea: carry enormous missiles, reach the launch area at high speed, and strike before the enemy could respond. Known to NATO as the Backfire C, this Soviet-designed bomber became operational during the 1980s and remains an important part of Russia's long-range aviation force. Its most recognizable feature is its variable sweep wing, which extends outward for takeoff and efficient cruising, then sweeps sharply backward for high-speed flight. Powered by 2 NK-25 afterburning turbofan engines, the Tu-22M can reach approximately 2,300 kilometers per hour, or around Mach 1.9, exceptional performance for an aircraft of its size. But the Backfire was not built simply to outrun other bombers. One of its primary Cold War missions was to approach heavily defended naval formations and launch powerful anti-ship missiles before carrier-based fighters could intercept it. The aircraft can carry up to approximately 24 tons of weapons, including conventional bombs, naval mines, and long-range missiles. Its signature weapon is the massive K-H-22, a high-speed cruise missile originally developed to threaten aircraft carriers and other heavily protected targets. Depending on its mission configuration, the Tu-160M can carry one missile beneath its fuselage and additional missiles under its wings. Russia has also developed the upgraded K-H-32, which is reported to provide greater range, improved guidance, and a more challenging flight profile than the original K-H-22. Weapons like these allow the Backfire to attack from outside the most heavily defended areas rather than attempting to penetrate them directly. This has gradually shifted its role from that of a fast attack bomber toward a long-range standoff missile carrier. Yet speed alone does not make the aircraft invulnerable. The Tu-22M is not stealthy, produces a large radar signature, and requires careful mission planning and supporting aircraft when operating against advanced defenses. The standard Tu-22M also lacks aerial refueling capability, limiting its reach compared with intercontinental bombers, such as the Tu-160 and B-52. Even with these limitations, few operational bombers can match its combination of near Mach 2 speed, heavy payload, and long-range missile firepower. More than 4 decades after it first entered operational service, the Backfire remains dangerous, not because it can secretly enter defended airspace, but because its missiles may allow it to avoid entering that airspace altogether. Few military aircraft are as instantly recognizable as the Tu-95MS Bear. Its swept wings, narrow fuselage, and 4 enormous turboprop engines make it look like a survivor from another age. But behind that Cold War appearance is one of the longest-range missile carriers still in active service. The original Tu-95 first flew in 1952, while the significantly updated Tu-95MS became operational during the 1980s and received the NATO designation Bear H. At the heart of the aircraft are 4 Kuznetsov NK-12MP turboprop engines, each producing approximately 15,000 shaft horsepower. Every engine drives 2 4-bladed propellers that rotate in opposite directions, creating the distinctive sound that has followed the Bear throughout its service life. This unusual power plant gives the Tu-95MS a maximum speed of roughly 830 kilometers per hour, making the Tu-95 family the fastest series-produced turboprop aircraft in the world. That is nowhere near the speed of the Tu-22M, but speed was never the Bear's greatest advantage. Its real strength is endurance, allowing it to remain airborne for extended periods and cover intercontinental distances, with aerial refueling extending its reach even farther. The Tu-95MS was originally designed around the K-H-55, a nuclear-capable cruise missile with a range of approximately 2,500 kilometers. 6 of these missiles can be carried on a rotary launcher inside the aircraft's weapons bay, while certain configurations were developed to carry additional missiles externally. Modernized aircraft can also launch the much larger K-H-101 and nuclear-capable K-H-102 cruise missiles from pylons beneath their wings. These weapons can travel thousands of kilometers along low-altitude flight paths, allowing the bomber to release them far beyond the target's immediate air defenses. The Tu-95MS therefore does not need stealth or supersonic speed to perform its primary mission. Instead, it can patrol at great distances, wait for launch orders, and send its missiles forward while remaining outside the most heavily defended airspace. The Bear is highly visible to radar and would likely require fighter, tanker, and electronic warfare support during demanding operations near contested regions. If forced to approach modern air defenses directly, its size, speed, and lack of stealth would leave it extremely vulnerable. But its standoff weapons are intended to prevent exactly that situation. More than 70 years after the Tu-95 family first took to the sky, the Bear remains relevant because its job is no longer to fly over the target. It is to carry long-range missiles close enough to let them complete the journey. The B-1B Lancer was originally developed for nuclear war, yet today it is the only bomber in the current United States Air Force fleet dedicated exclusively to conventional missions. Known to its crews as the Bone, it has evolved into one of the most powerful conventional strike aircraft ever placed in service. First delivered to the Air Force in 1985, the B-1B combines the reach and payload of a heavy bomber with a level of speed rarely found in an aircraft of its size. Its variable sweep wings extend to a span of nearly 42 meters for takeoff, landing, and efficient cruising, then sweep backward to just over 24 meters for high-speed flight. 4 General Electric F-101GE-102 afterburning turbofan engines power the aircraft, each producing more than 30,000 pounds of thrust. Together, they can push the Lancer beyond 1,400 kilometers per hour, or approximately Mach 1.2, making it the fastest bomber currently operated by the United States Air Force. But its most impressive figure is not its speed, it is the amount of firepower carried inside its fuselage. The B-1B's 3 internal weapons bays can hold up to 75,000 pounds, or approximately 34 tons, of conventional ordnance, giving it the largest conventional payload in the American bomber fleet. Depending on the mission, that load can include precision-guided bombs, naval mines, or as many as 24 AGM-158 JASSM standoff missiles. A 4-person crew operates the aircraft, manages its defensive systems, navigates to the target area, and controls the release of this enormous weapons load. Its terrain-following radar was designed to support high-speed flight at low altitude, allowing the bomber to use the landscape to reduce its exposure to enemy radar. The B-1B is not a true stealth aircraft, but its blended wing body design and reduced radar signature were intended to improve its survivability against heavily defended targets. Its conventional firepower has also been demonstrated in combat. During Operation Iraqi Freedom, the B-1B flew less than 1% of the combat missions, but delivered approximately 43% of the JDAM precision bombs used. That performance demonstrated the Lancer's defining advantage. It can remain available over a combat area, receive updated targeting information, and strike multiple targets during a single mission. However, decades of demanding missions, high operating tempos, and structural wear have made the aging fleet increasingly complex and expensive to maintain. Even with those limitations, the B-1B still offers a combination of intercontinental reach, supersonic speed, and massive conventional payload that no other American bomber can fully replicate. The Lancer may have left its original nuclear role behind, but it found a new purpose as a high-speed arsenal capable of delivering the firepower of an entire strike package from a single aircraft. The B-52H Stratofortress is neither stealthy nor supersonic, and the last example rolled out of the factory more than 6 decades ago. Yet, while several newer bombers have entered service and disappeared, the B-52 has continued adapting to almost every major change in aerial warfare. The first B-52 flew in 1954, while the current H model began joining the United States Air Force in 1961. Powered by 8 Pratt & Whitney TF-33 turbofan engines, each producing up to 17,000 pounds of thrust, the enormous aircraft can reach approximately 1,050 kilometers per hour, or around Mach 0.84. That makes it considerably slower than the B-1B, but the Stratofortress was never designed around speed alone. Without aerial refueling, it has a combat range exceeding 14,000 kilometers, while tanker support can extend its reach until crew endurance becomes the primary limitation. A 5-person crew flies the aircraft, manages its navigation and electronic warfare systems, and controls one of the broadest weapon selections available to any combat aircraft. The B-52H can carry approximately 70,000 pounds, or 31.5 tons, of mixed ordnance inside its weapons bay and on pylons beneath its wings. Depending on the mission, that payload can include conventional gravity bombs, precision-guided JDAMs, naval mines, air-launched cruise missiles, standoff weapons, and electronic decoys. In certain configurations, the aircraft can carry as many as 20 air-launched cruise missiles, allowing even a small formation of B-52s to release a large number of weapons from outside heavily defended airspace. It also remains capable of performing both conventional and nuclear missions, a role that separates it from the conventional-only B-1B. The bomber's firepower has repeatedly been demonstrated in combat. During Operation Desert Storm, B-52s delivered approximately 40% of all weapons dropped by coalition air forces. Its endurance was displayed again in 1996, when 2 B-52Hs completed a 34-hour, 16,000-mile round trip from Louisiana to strike targets in Iraq before returning to the United States. Despite that extraordinary range, the Stratofortress has serious limitations. Its large radar signature makes it poorly suited to penetrating modern air defenses, pushing the bomber toward missions built around long-range weapons launched from safer positions. What keeps the B-52 relevant is its ability to accept new sensors, targeting systems, communications equipment, and weapons without replacing the entire aircraft. That flexibility is now driving another major transformation, with Rolls-Royce F-130 engines, an advanced radar, and upgraded digital systems planned for the future B-52J configuration. The United States Air Force expects the bomber to remain operational into the 2050s, meaning some airframes could serve for nearly a century. The B-52H has survived not because its age no longer matters, but because its extreme range, heavy payload, and continuously expanding arsenal remain extraordinarily difficult to replace. At more than 54 meters long and capable of weighing approximately 275 tons at takeoff, the Tu-160M has the dimensions of a large passenger aircraft, but it can fly at more than twice the speed of sound. Known to NATO as the Blackjack and nicknamed the White Swan in Russia, it is the largest and heaviest supersonic combat aircraft ever built. The original Tu-160 first flew in 1981 and entered Soviet service in 1987, while the modernized Tu-160M introduces upgraded engines, avionics, navigation equipment, radar, communications, and electronic countermeasures. Its variable sweep wings extend to almost 56 meters for takeoff and efficient long-range cruising, then sweep backward to approximately 36 meters for high-speed flight. Power comes from 4 NK3202 afterburning turbofan engines, each capable of producing roughly 55,000 pounds of thrust. Together, they can push the enormous bomber to approximately 2,200 kilometers per hour, or around Mach 2.05, making it one of the fastest operational bombers in the world. Despite that speed, the Blackjack is also built for extraordinary distance. It can fly approximately 12,000 kilometers without aerial refueling, while tanker support can extend its reach much farther. A crew of 4 operates the aircraft and manages a maximum weapons capacity of approximately 40 tons, all carried internally to reduce aerodynamic drag. Inside the fuselage are 2 large weapons bays, each equipped with a rotary launcher capable of holding 6 cruise missiles. This allows the Tu-160M to carry as many as 12 long-range weapons, including the conventionally armed KH-101 and the nuclear-capable KH-102. These missiles can travel thousands of kilometers after launch, allowing the Blackjack to strike without approaching the target's strongest air defenses. The bomber can use its speed to reach or leave a launch area quickly, while its range allows it to threaten targets across enormous distances. But despite its smooth shape, the Tu-160M is not a stealth aircraft. Its immense size and radar signature would make direct penetration of modern air defenses extremely dangerous, while its complexity demands extensive maintenance and specialized infrastructure. The modernized version addresses some of these limitations with improved electronic warfare, more efficient NK-3202 engines, and extensively upgraded onboard systems. Even so, the Tu-160M's real protection does not come from invisibility. It comes from distance, speed, and the reach of its missiles. No other operational bomber combines this level of size, supersonic performance, intercontinental range, and long-range missile capacity in quite the same way. The Blackjack was not built to remain quietly over a battlefield. It was designed to carry a dozen strategic cruise missiles to a distant launch area faster than any subsonic bomber could manage. Most bombers in this countdown survive by launching their weapons from outside heavily defended airspace. The B-2 Spirit was built for a far more difficult mission: penetrate those defenses, reach the most protected targets, and strike before the enemy can organize an effective response. First flown in 1989 and declared operational in 1997, the B-2 remains one of the most advanced and closely guarded aircraft ever placed in service. Its distinctive flying wing shape is not simply futuristic styling. Blending the fuselage into the wing and eliminating the vertical tail reduce the number of surfaces that can reflect radar energy. Composite materials, radar-absorbing coatings, buried engines, and carefully managed exhaust signatures further reduce its visibility across radar, infrared, acoustic, electromagnetic, and visual detection systems. Stealth does not make the B-2 invisible, but it can significantly reduce detection range and leave enemy defenses with far less time to track and engage the aircraft. 4. General Electric F118GE100 turbofan engines power the Spirit, each producing approximately 17,300 pounds of thrust. The bomber travels at high subsonic speed and can operate at altitudes of approximately 50,000 feet, prioritizing efficiency and low observability over supersonic performance. Without aerial refueling, it can fly roughly 11,000 kilometers, while a single refueling can extend that distance to approximately 18,500 kilometers. Remarkably, this intercontinental bomber is operated by only two pilots, a pilot in the left seat and a mission commander in the right. Hidden inside its flying wing structure are two internal weapons bays capable of carrying up to approximately 60,000 pounds, or 27 tons, according to current United States Air Force figures. That payload can include conventional precision-guided weapons, nuclear bombs, and specialized weapons developed for targets buried deep underground. Among the most significant is the 30,000-pound GBU-57 Massive Ordnance Penetrator, a weapon so large that the B-2 is currently the only operational aircraft capable of carrying it. On June 21, 2025, 7 B-2s completed a mission lasting more than 30 hours and conducted the first combat employment of the GBU-57, demonstrating the aircraft's ability to combine stealth, global reach, and an exceptionally heavy precision payload. But this capability comes at an extraordinary cost. Only 21 B-2s were built. Each aircraft requires specialized maintenance, and its low observable surfaces demand careful inspection and protection. The limited fleet means that every aircraft, trained crew, and maintenance team represents a resource that cannot be replaced quickly. Yet no other operational bomber currently combines this degree of stealth, intercontinental range, penetrating capability, and precision firepower in a single platform. The B-2 earns the #1 position not because it carries the largest payload or flies the fastest, but because it can perform the mission most other bombers in this countdown are designed to avoid: entering highly defended airspace and striking from within. From Cold War survivors to stealth aircraft capable of crossing the world's most heavily defended skies, these 7 bombers prove that power can come through speed, endurance, payload, or invisibility. But which one do you believe deserves to be called the most feared bomber still flying today? Share your choice in the comments and subscribe to NOLOFACT for more stories about the machines shaping modern warfare.